Howdy there. This is a video about something called rationalizing the denominator of a fraction, and mathematicians are notoriously fussy and picky about having radicals or square roots or cube roots in the denominator. They just don't like them, and so we need to rationalize them, which is the process of getting rid of that fraction in the denominator. And so we're going to talk about two examples, and then I'm going to give you an opportunity to try two examples based on these. So I strongly recommend, in fact, if you're in my class right now, I'm expecting you to write these problems down as you watch this video. So in this, you're asked to rationalize the denominator, but it doesn't look like there's a cube root in the denominator, but I'll show you what that looks like. If you use one of the properties we talked about, this could be rewritten as the cube root of 2n divided by the cube root of 9m, and now we have a cube root in the denominator, but that's problematic. So if we are familiar with cube roots, that I need three identical things to be pulled out of a cube root, so we'll rewrite this as 2n over. Now I'm going to be really picky here, right? So I want three things multiplied, but I know that 3 times 3 is 9. So instead of 9m, I'm going to write 3 times 3m. Well, if I want to get rid of, quote unquote, get rid of the cube root, I need 3 3's there. But I don't have 3 3's there. I only have 2 of them. And I'll also need 3 m's there. But I don't have 3 m's. So I need to be clever and multiply by the things that I'm missing. So if I want another 3, I'm going to multiply by 3. So now, when I multiply these, it's going to be 3 times 3 times 3, that blue 3. And I need to multiply by m times m. So I'll write it out, and maybe you'll see where this is going in just a minute. In order to multiply like this, this thing right here is really just a fancy version of 1 that I'm multiplying by, like we talked in our rational equations unit. So if I multiply by that, I get the numerator becomes the cube root, and we're using one of those properties, 2 times n times 3 times m squared on the numerator. And then on the denominator, I'm going to get the cube root, the cube root of 3 times 3 times that blue 3 times the m that I had before, this m, times the 2 new m's that I'm multiplying by. I don't know why that happened. M and m. Clean up that radical. There we go. All right. So what is this? This is the cube. It should be cube root. Cube root of 2 times 3 is 6. N times m squared is nm squared. Okay, that cleans itself up. Well, with a cube root, I need 3 things to pull out. So I pull out a 3. And I pull out an m. So now this is no longer a radical function on the denominator, and we've got our answer. So this is rationalized. It has a rationalized denominator. It is equivalent to what we started with, but it doesn't have the square root, or the cube root in this case, on the denominator. And there's lots of other ways to write this, right? These m and this n can switch places. We could simplify like this, but this is pretty much the most simple that it gets. So we'll do another one at the end of the video, but really just to overview, we cleverly multiplied by something that would get us 3 3's because it's a cube root, and 3 m's because I needed 3 of them. And to do that, I had 2, I needed 1 more. I had 1, I needed 2 more m's. So pause and think about that, and ask questions in class if you have a question about it. All right, so this is a little different than the previous one because it's actually an addition sign. The previous one had a multiplication sign in between there, and this is now an addition, but it has a square root on the denominator. And we have to multiply by something called the conjugate, and we've talked about this in class, but I'll just remind you what the conjugate is. The conjugate is basically the same thing, but with an opposite sign. So instead of 2 plus square root 5, it's going to be 2 minus the square root of 5. And this really comes from the difference of squares idea. So what we do to the bottom, we got to do the top, because this is my fancy version of 1 up there that I just circled. 2 minus square root 5 over 2 minus square root 5, that's just a fancy version of 1. And I know there's no x's in here, which kind of makes this nice. So if I multiply these out, this is a binomial, right? This is a binomial, and this is a binomial. And so 1 times 2 minus the square root of 5 is going to be 2 minus the square root of 5. That's easy. But down here on the denominator, this is really a FOIL problem. It's 2 times 2, 2 times root 5, so negative root 5, so negative 2 root 5. Root 5 times 2, so plus 2 root 5. And root 5 times root 5, so we'll write that as, actually it's negative root 5, so negative root 5 squared. Now why is it negative? It's negative because that's a negative, and so that has to be a negative. Let's clean this up. So I hope that you see that those are going to cancel each other out. And so you'll be left with 2 minus the square root of 5 over 4 minus, because it's still a minus sign, and the square root of 5 squared is just 5. Oh, that's handy. This cleans up to 2 minus root 5 over negative 1. And for the purposes of this class, I'm happy with that. But you could also say, hey, this is negative 2 minus root 5, or you could even go further and say this is root 5. Oh, actually, I'll do it another step. You could say this is really negative 2 plus root 5, or you could say that this is root 5 minus 2. So, right, all of these, for me, are really acceptable answers. Just kind of playing with the numbers a little bit. So this is because, just notice, why did we have to distribute here? It's because it was a plus and a minus sign. If it was multiplication, we could kind of do what we did in example 1, but this is with addition on the denominator, and we had to strategically multiply by this blue stuff, which was the conjugate, which is the first number is the same, the sign changes, and the second number is the same. So I want you to try with these two, and go ahead and pause the video and give them a shot. You know, the more you practice these, the better you're going to get at them. All right, hopefully you've given it a shot. We'll talk about this first one first. What I'd like to do is there's a few ways of being relatively clever, right? So this is a 5th root. So to get anything off this denominator, I need 5 of them. I've got 3 of them here, and 16. There's some fun stuff we can do with 16. So actually, let me play with the number 16 first, right? 16 can be broken down into 4 times 4, and 4 can be 2 times 2. Ooh, goodness, what happened there? 2 times 2, and 4 can be broken down into 2 times 2. So we'll use the property. So we got the 5th root of 7 over the 5th root of 16 x cubed. That's our first step, and we'll just kind of clean it up over here. So we still have the 5th root, ooh, that's really big. The 5th root of 7 over the 5th root of, well, 16 can be rewritten as 2 times 2 times 2 times 2. Hey, there's 4 2's there. I need one more. And x to the 3rd power is x times x times x. So I'm trying to be really strategic about what I need to multiply by. Some folks might have stopped at 4 times 4, and in that case, your problem's just going to be a lot bigger, and it's okay if you did that. You'll have to multiply by more. All right, so we'll strategically multiply by the 5th root of 2 times x on the denominator, and we've got to do the same thing on the top. 5th root, 2 times x times x. So we'll get, on the numerator, we'll get the 5th root, oops, that's the 5th root of 7 times 2 times x times x. And on the denominator, we're going to get the fifth root of 2 times 2 times 2 times 2 times our new blue 2 times x times x times x times our two new x's. And for every 5 of them, because this is a fifth root, for every 5, it can come out. So I got 5 of them there, that comes out as a 2. I got 5 of them there, that comes out as an x. And on the top, 2 times 7, so the fifth root of 14x squared. And that, my friends, is our final answer. Right? That doesn't simplify anymore. But it's the fifth root of 14x squared over 2x. Hopefully you had a chance to try the second one, and I'm going to zoom out so that you can still see both of them at the same time. We're multiplying strategically by 2 plus root 3 over 2 plus root 3. That's the conjugate. It's the same first number, change the sign, same second number. Now these are both binomials, so I have to FOIL the top and FOIL the bottom. I have to distribute. I'm going to pause the video to speed it up. All right, so I've taken a moment to distribute them, and I just want to clarify some things. Negative root 2 times positive root 3 is negative 2 times 3 square rooted, right? We're using one of our properties. And the negative square root of 3 times positive square root of 3 is negative 3. It's negative 3 times, it's 3 times 3 under a square root. They cancel each other out. So I hope that you notice that these are like terms and will cancel. So boom, boom, gone. So that is 10 plus 5 root 3 minus 2 root 2 minus root 6 all over negative or positive or 4 minus 3, or maybe we could rewrite that as just 1, right? 4 minus 3 is 1. So we would prefer this over having a radical in the denominator. And I know that's complicated and strange and weird, but you know it's the way the cookie crumbles. So we want to make sure that we get rid of those on the denominator. I know this is a long video. Thanks for watching.